Okay, naming acids. So the first way to recognize an acid in any compound is if it starts with an H. If any compound starts with an H, it's an acid, except for H2O, which is water. We know what that is. So I would get used to knowing that because we will be identifying acids as well as other kinds of compounds. But you definitely need to know how to recognize an acid right off the bat because it starts with an H or a hydrogen. So, for example, it has HCl, HNO3, H2SO4. So there's different kinds of acids. So a binary acid is thinking the same way as the simple binary naming, where it's just an element plus an element. A binary acid is just hydrogen plus one other element. So this HCl up here is a binary acid, whereas these two right here are not because they have more than one element. So they have a polyatomic on them. So naming binary acids is super easy. It gets the word hydro in the beginning, right here. My pen wasn't working. And you keep the root word of the anion, and then you add the IC to the ending of it, and then the word acid. So the way to identify a binary acid is because it starts with the word hydro. So let's do some practice. All right. So we have HF. So this will start with hydro. This is a big marker. F is fluorine, but remember we were dropping the ending and adding IC, so it will be fluoric, and then the word acid. All right, for this one, it's an acid, starts with H, so we have hydro. Br is bromine, so it's bromic acid. H2S, you don't have to worry about this because we are just naming it. We're not trying to cross charges or anything like that here. So hydro. S is sulfur, so it'll be sulfic acid. Now it starts to get complicated when we're looking at polyatomic ions in acids. So looking under number 1 over here, right here. So if the suffix is ITE, so any of the polyatomics that end in ITE, you change the ending to OUS. Then you use the word acid. So the polyatomic ClO minus is hypochlorite. That ending gets changed to OUS, so it becomes hypochlorous acid. So HClO2 is a polyatomic ion of ClO2 minus, which is chlorite. So HClO2 is chlorous acid. If the polyatomic ends in ATE instead of ITE, you change the ending to IC and you still use the word acid. So this HClO3 has a polyatomic ion of ClO3 minus. ClO3 minus on your polyatomic ion sheet is chlorate. So when it becomes an acid and it has hydrogen, you drop that ATE and add IC in the word acid, so chloric acid. So then HClO4 has the polyatomic ClO4 minus, which, one second. Sorry, I had to cough. Which is perchlorate. So HClO4, you get rid of the ATE and add IC, so it would be perchloric acid. Okay, let's do some examples down here. Actually, I want to go back to this. One thing that it would be helpful to remember when you are wondering which ones get changed to ITE, which ones get changed to ATE, I always teach it like this. Remember, whoa, that's a big marker. I ate something icky. Ate gets changed to IC. Well, I should underline the K too. So if you can remember ate and ick, I ate something icky, you can remember that the other one gets changed to OUS. So it is IC, and then ITE is OUS. That would be a good thing to remember. Okay, some examples. So the first thing you should look at and see is if there's a variable charge, maybe. There shouldn't be. These are acids. They all should start with H. Or a polyatomic, which all of these have polyatomics in there. And I would put the polyatomics in parentheses. So the hydrogen, first off, we should identify that all of these are acids because they start with H. So we're going to put the polyatomic ions in parentheses, and then we're going to name it. So we have this polyatomic, which is acetate. Remember the rules for polyatomics. I ate something icky, so this gets changed to IC. So we keep ACE, IC, acetic, and then add the word acid. And if you're wondering, this is vinegar. Acetic acid is vinegar. All right, next one, we're going to put the polyatomic in parentheses so we can separate it. It's an acid because it starts with H. Then we need to find BrO3 on the polyatomic ion sheet, and it is bromate. So ATE, I ate something icky, ATIC, and this is bromic acid. All right, next one. This 2 is only here because the SO3 has a -2 charge. That's the only reason it's there. We don't have to do anything special. So we're going to put the polyatomic in parentheses, and you find SO3 on the polyatomic ion sheet, and it is sulfite. So ITE gets changed to OUS. So this is sulfus acid. So here are some general directions on how to determine. It's kind of just the written out way of what I've already said in this video in case you prefer to read them than listen. All right, now we've gone from the formula to the name, and we're going to go from the name to the formula. So right off the bat, we see the word acid, and we should think hydrogen. So this is H+. I'm going to write it for all of them. Now I want you to remember hydrogen's always first, but the word acid is second, so that's why I'm writing the H underneath of all of them. So sulfic, which I see, here, let's put this over here. I ate something icky, so then ITE gets changed to OUS. So if this is ending in IC, we know that it was 8. So this was sulfate. So now we can figure this out. Sulfate is on the polyatomic ion sheet, and it is SO4 -2. So I'm going to take these back over here because H is first, or hydrogen's first. And then we have SO4 minus 2. And then just like the other element or compounds that we were working with earlier in this section, you cross the charges. Remember, the 2 goes down here and the 1 goes down here. So this is H2SO4. All right, nitrous, OUS, means that it was ITE. So this was nitrite. So then we find nitrite on the periodic table, and it is NO2 minus 1. So then we can rewrite both of these elements over here and the polyatomic ion over here so we can cross the charges and it's easier to see. So the 1's cross, and this is HNO2. All right, next one. Now you're immediately going to go to the IC, but this word hydro in front of it means that this is a binary acid. We only add the word hydro when it's a binary acid. So if you're like, what's binary acid? Go to the beginning of this video because that's when we talked about the binary acids. Hydro means it's just an element. Iodic means that it's iodine. So iodic is iodine, so it's I. And iodine has a -1 charge. So then we can rewrite this over here. So we have H plus, and then we have I minus. We'll cross those charges, they're just 1's. And it is HI. And that is going for naming acids, going from the name to the formula.